Hi, it's Craig again, sat on the sofa again. So, what we're going to talk about today. Let's talk about overcurrent relays. You'll find these in starters, such as a direct online starter, which is typically used for smaller induction motors, or a star delta or Y delta starter if you're an American. Starter delta starters, as we call them in the UK. Which are motor starters, and you'll also find them in auto transformers, etc., which is another type of starter used in the marine industry, for example. So, overcurrent relay. There's three different types. There's a thermal type, a magnetic type, and an electronic type. Okay, what the function of an overcurrent relay is, as the name suggests, is to work well. Basically, overcurrent relay, if you get overcurrent, it cuts the circuit. That's basically what it does. What might cause overcurrent? Right, well, there's a few things. One, you could have a what's known as a single phasing fault. That is, in a three-phase induction motor, you have three wires going in. There's three coils inside in what's known as the stator. Now the stator, if one of the connections to one, so three-phase electricity going into the three coils, generating a magnetic field, turning the rotor, turning the motor. If one of the connections broke, say there's a fault in the coil itself or in the feed wires going to the motor, that can cause what is called single phasing. So the motor will run rough, the current will increase, and generally things you don't want. So if you've got more current then going through the two remaining supply wires, that is not good, because the system wasn't designed for that. The wiring wasn't designed to carry that much current. So that'd be a reason you'd want single phasing. Sorry, a reason why you'd want an overcurrent relay. Ignore that. So single phasing. So one of the connections to the motor is cut for some reason. Which could be, like I say, it could be a variety of things: a fault with the coil, fault with supply wires that have got broken, got chopped, connections come loose, current increases. You don't want the motor to carry on running, because the motor might be tucked away somewhere, and even though it's running roughly, you don't notice. So the overcurrent relay will detect this and cut the supply, and then you'll realise it's not working and go and investigate. Another reason why you might need an overcurrent relay, well, you will need, is when you start an induction motor, there's a thing called an inrush current, an initial current which is maybe 5 to 7 times higher than the operating current of the normal operating current of the motor. A bit like a car. When you accelerate a car from 0 to 60, you're going to use more fuel initially to get it up to speed than you will when you're cruising. So the trouble with this high initial current you're going to get when you press the button and switch it on is I've totally lost my thread now. Hang on. I'm back again. I stopped the video for a minute because I thought, where am I going with this? Because I'm just making this well, not making it up, but I'm talking off the top of my head without a script, and I've only just decided that I was going to talk about overcurrent relays. So I thought, well, what's the connection between overcurrent relays that I'm talking about and the inrush current when you start the motor? Right. What I was going to say is, you've got the inrush current when you start the motor. There's a feature in an overcurrent relay. There's a time delay, because if you didn't have the time delay before it cuts the supply during overcurrent, the initial inrush current, the higher current when you start the motor, would trip the overcurrent relay. That's what I was actually gonna. That's where I was going with me previous video before I cut it a minute ago. So, start the motor, and it doesn't trip the overcurrent relay because there's a delay. But if you had high current, and how the level at which the overcurrent relay will trip is adjustable. If you had a high current for a sustained period of time, so for example, if the overcurrent relay was set to trip after a second, after a second you still got higher than normal current, it will trip the overcurrent relay. But the delay is long enough so it doesn't trip when you start the motor due to the high initial current. That's what I was going to say, but I had to stop the video and think about it for a minute. Yeah, so just to recap, overcurrent relays, 3 types: magnetic, thermal and electronic. You probably come across electronic and thermal more. Magnetic ones are quite rare. Probably come across electronic ones more these days, but they're designed to trip when you've got a high current, higher than the should be in the circuit. And overcurrent relays are put in starters such as star delta starters and direct line starters, etc. So when it takes a high current, higher than it should be, which is probably could be caused by something like single phasing, where one of the supply wires is cut, or there's a fault in the stator coil, cuts the supply, but it doesn't do it instantly. And it doesn't do it instantly because there's a set delay in the overcurrent relay, so that when you start the motor, the inrush current, which is the high initial current, doesn't trip it. You have that time delay because that inrush current will quickly drop as the motor starts, if that makes sense. If not, get in touch. Okay, it's Craig here, and I hope that's been useful. Thanks very much. I'll see you soon.